Hi guys, I hope so. We started with the Hadoop Big Data from the last lecture, and let me share my screen, and we are going to continue today's lecture. Okay. So what we discussed in the last lecture? In the last lecture, we have discussed about roles and responsibility as a data engineer. Then we discuss about how can we start our career as a data engineer. So in the data engineer, as I said, that you should have some prior knowledge about the SQL, Linux, then you can talk about the Python. And if you have some knowledge about the cloud, then that will be really, really good. And some basic knowledge about the shell scripting. And this is the way you can start your career as a big data engineer, or we called it as a data engineer. So when you know any type of cloud, let's say you take example of GCP, AWS, Azure, or any other cloud. So basic understanding about the cloud technology will help you to gain more knowledge about the data engineering, and it is also helping you to get more opportunities as a Oracle DB, as a Hadoop developer. Okay, so we discuss about the big data system yesterday. Now we'll try to understand that what are all components that we need to understand about the big data. So let me take the diagram over here. I'll just copy that. Okay, let me copy it and let me paste it here. So this is the Hadoop ecosystem. So what we got to know that there are different type of datas you will get, right? You may get the structural kind of data. So when you have a source data which is coming from different sources, okay, let's say you have a sources and you're and it is generating a huge amount of data. What you are going to do, you are going to process that data, and after the processing you are going to store that data into some location. Okay, and this output you are going to use to increase your business. Okay, that's the way like the whole processing get happen. But since we are getting a different type of data, like as I said that we get the structural data, we get the semi-structural data, we can get the non-structural data also. Now when you want to process huge amount of data, and another thing is when you have a different type of data are available and you want to process this data, when you want to process this data, for that we have a big data systems are there, and in the big data system there are multiple Hadoop components are there, Hadoop ecosystems are there, which is going to help you to process huge amount of data. So among that, the one which is going to play a very important role, we called it as a Hive. You can see here it is a Hive, and below that it is mentioning it as SQL query. So what is Hive? Okay, what is Hive? So Hive is just like your database only, just like your database only. I'll tell you one small example. Let's say I have some data is available in the text file. Okay, in the text file I have huge amount of data is there, which is a comma separated data is there. Let's say ID is 1, name is let's say Chetan, salary is comma 1000, and 2, second name is let's say Sagar, salary is 2000. Likewise we have huge amount of datas are available, huge number of datas are available here, like let's say 10 million records are there. So what you can do, by looking to this data only, you can say that okay, this is looks like a structural data because it has some format. So first of all you have ID, then comma name, then comma salary. What you can do, you can load this data to the tables, and that table we called it as a Hive table. So whenever you have a data which is available in the form of file, but if that data looks like a structural kind of data, you can store that data in the form of Hive table. And in the Hive table looks like your Oracle table or MySQL table only, which is in the form of rows and column. And on this Hive table, you can run your Hive queries, like Hive queries, you can run it over here. The way we run our SQL queries, right? Here, since it is a Hive database, but it's not a complete database, because when you say a database, it needs to perform the all the operations like insert, update, delete, commit, rollback. Everything is not supported over here. So what Hive is saying, that Hive is completely related like a SQL only. So those people who have some knowledge about the SQL, those people who have a knowledge about the SQL, they can easily understand this Hive technology. So what is Hive? Whenever you want to do some analytical kind of things, let's say you have a data, you are going to load that data into the Hive tables, and on these Hive tables you can run your select statement, you can do your reporting kind of jobs, you can do joins, you can do select, you can do everything on these Hive tables, and finally you will get a data, and that data you can use, that data you can use for your, maybe if you want to see that into the display and all, you can see that. So Hive is mainly useful when you have a huge amount of data, and that is the structural data. The most important terminology is whenever you have a structural kind of data is there and you want to process structural kind of data, that time you can use Hive. And this is one of the important component of your Hadoop. So whenever you are searching a job for the Hadoop developer, the people will definitely ask the questions on Hive. So in the Hive, there are multiple components, multiple concepts are there, like partition, external table, internal table, and multiple other important concepts are there which needs to be understood for the Hive. So if I want to talk about what is Hive, Hive is basically when you want to process your huge amount of structural kind of data, you can easily load your data from your CSV to this Hive table. It is easily can be done. Now another component that you can see over here is your HDFS. This is also one of the very important concept, Hadoop distributed file system. Now what is meant by HDFS? What is meant by HDFS? Normally what we do, like if I take the example of this Windows operating system, we store our data on the file system, right? Like I have a C drive, D drive, right? There I am storing my data. And this file system is basically a small block only. Your data, let's say I'm saying that, okay, I want to store some image or photo. That image or photo get basically stored on your this block only, where it is getting stored on this file system block. But this file system block are very small, maybe in 4 KB to 8 KB. It's in KB only, it is very small actually, because you are storing a data, that data is very small, like let's say the image size will be hardly 2 MB or 8 MB or hardly 20 MB, not more than that. So you are going to store small data. But if you replace the same thing with your big data system, if you replace the same thing with your big data system, the block size will be bigger. Why it will be bigger? The block size, it will be bigger. It can be 128 MB. Why? Because you are going to store a huge amount of data. Now let's say I want to store my one file which is of size 1 GB, which is around 1024 MB basically. So how many blocks I will get? How many blocks I need to allocate here? I need to allocate only 128 into hardly 8 blocks, 8 or 9. Just do the calculation. Means 1024 divided by 128 MB. So whatever comes, let's say 8 block, it will be used only 8 blocks. But if you are not using a block size of 128 MB, if you are using 8 KB, then you can see that how many blocks you need to use, maybe 8000. So in the HDFS is basically to store your huge amount of data. What is the purpose of HDFS? Whenever you want to store your data in the big data, you are going to use Hadoop file system. What file system you are going to use? You are not going to use this Windows file system and this normal file system. We need to use a big data file system, and we called it as a HDFS, Hadoop file system, which is going to store your huge amount of data, and that is called HDFS. So what is the main difference between HDFS and your Windows file system, or you take the example of Linux operating system file system also? The main difference is the HDFS is having a very big block size. The block size is 128 MB. Why it is 128 MB? Because you cannot expect that in the Hadoop you will have a small file. You are expecting that your file will be in maybe in GB at least. Let's take example 100 GB. So when you have a huge amount of data and you want to process huge amount of data, you need a storage, right? You need a storage, and that time we are going to use a storage. We called it as a Hadoop file system, HDFS. And same sort of storage, if you replace with the cloud, like you may have heard about the terminology called Amazon S3, right? S3. This is also distributed file system. Distributed means your data will not be stored on single node. Your data will be distributed among the different node. What does it mean? Let's say I have multi-node Hadoop cluster is there, okay, and this Hadoop cluster will have a HDFS over here, HDFS, okay, and this will be connected like this. So when you are saying that I want to load 100 GB of data, that 100 GB of data will be stored from here, here, or here. It will be stored anywhere, because your data get distributed among the nodes. That is called distributed Hadoop file system. And that's the reason we need a big file system, and that is called HDFS, a Hadoop file system. So till now we got to know about the what is the importance of Hive, what is the importance of Hadoop file system. There is one more important component here that you can see right now is Yarn. Yarn is a resource manager. Yarn is a resource manager. So resource manager means, if I want to tell you one small example, let's say I have a CSV file and I want to process this CSV file, right? I want to process this CSV file, and after processing means, let's say I'll in the processing I'll do some filtering, joining. After processing this file, I'm going to store that output into some location. It can be your HDFS also, right? So when you process it, like when you read a CSV file, you are going to do some filter, you may be doing some group by, join, whatever processing you are doing. In order to do that processing, it needs some resources, right? It needs some memory, it needs some CPU, number of cores, number of cores per executors, whatever things you need, that resource manage will be taken care by the resource manager, and we called it as a Yarn. So whenever you run your any Spark job, let's say you are running any Spark job, let's say you are running any Hadoop job, okay, you need a resource manager who will do the negotiation of your resources, who will do the negotiation of the resources for you, and that resource manager we called it as a Yarn. What we are calling it as a Yarn? We are calling it as a Yarn. Yarn is a resource manager. So we need to understand about what is the importance of Yarn, how it works, and that we are going to talk about. Here you can see that MapReduce is also there. Here you can see one more important component is MapReduce. So today's lecture, like I'm just giving you the heads up, okay, and we are not going much details, but I'm just trying to make you some comfortable with this technology. So one more component is there, we called it as a MapReduce. I'll tell you the small example of MapReduce. Let's say I have one CSV file is there. In that CSV file I have written something. What I'm trying to do, I want to do the word count program. Word count means how many hi, hello, Oracle, Hadoop, how many words are there. I want the count. So that processing will be done by your MapReduce program. MapReduce means basically it can be your Java or Scala program. So basically, while you are doing the processing, you need to write down some program which will read this file and it will give me the output, like how many high are there. Let's say 3 highs are there, how many hellos are there, 4 hellos are there, how many oracles are there, 5 are there, how many Hadoops are there, 10s are there. So these are the number of words which are available into this file, and when you count it, that you are going to count it by doing some processing, and that processing can be done by using your MapReduce. So MapReduce is basically a programmatically paradigm. It's a programming thing. What is this? It's a programming. You need to write down the program to understand that how many words are there. Just an example. So MapReduce is basically a programming to achieve your goal. And one more important thing is why you are not using a plain Java, why you are using a MapReduce, because we need a mechanism which will take the data from your Hadoop file system, which can read a data from your Hadoop file system, and it will process a data parallelly also on different node. So when this MapReduce was not there, the scientists were thinking about they need a programmer, they need a programming technology in a such way that it will take the data from Hadoop distributed file system, it will receive a data from it will receive a data from the HDFS, and they want to process it on different nodes. Let's say I have 3 nodes are there, so my MapReduce will work here, here and here, and it will process their data, respective data from here. So basically the coding should be also get distributed, and that is the reason they have come up with the programmatical technology. We called it as a MapReduce. But nowadays, why MapReduce people are not using? Because it is slow. It is very slow. The processing of your MapReduce was very slow, and that is the reason people were looking for an options which is at least 100 times faster than MapReduce. Let's say you want to select a data, let's say you want to do some joins. For small thing only, the MapReduce program was running. I will tell you an example. Let's say I have one CSV file is there and I want to do some filter. I have a data of USA, America, China and India. I want to filter out only India data. I want to filter out only India data. So this is very difficult, if you are writing down the MapReduce program, first of all, you need to write down the program to read this file and then do the filtering. It's not that easy. For small thing also, you need to write down a big program. And again, the intermediate operation was stored on your disk level. Like small intermediate operations will be there that you need to store it on the disk level. I'll tell you one example. Let's say I have one file is there which is of 1000 line. Then you are doing some filter operation, and after filter you got the number of record it as, let's say, 600. Again you are doing some filter and finally you got the number of records are 300. From this 600 you got 300, from 1000 you got this 600. So what is the problem with the MapReduce? That this intermediate, because this is an input, right? This is a input for this 300. For 300, which is the input, this is the input. So you need to save this intermediate output to the disk level. The problem with the MapReduce was this intermediate result, means this 600, first of all you need to write it to the disk, then again it was reading it, then again it was doing a filter, and again then you are writing it to the disk. Because there is no concept of memory here. In the MapReduce, all the intermediate operations were doing it on the disk. Try to understand one thing, that when you are reading something from the disk or whenever you are writing it to the disk, this is very costly operation. Costly means which is a time consuming operation. So we always try to avoid doing read and write from the disk level, and this was happening with the MapReduce program, and that is the reason this MapReduce got replaced by the Spark. You may have heard about the technology called Spark. Because why Spark is very faster? If I take the same example, let's say I have a CSV file and you are doing the filter 1, and after 1000 record I got 600 record in the filter 1. Again, I don't need to write this 600 record to the disk. I can store this 600 record into a memory, and again I'm going to do some filter 2. Here I will get 300 record, right? This 300 record again I can store it into the memory itself. So when you are doing the filter 2, whenever you are doing filter 2, filter 1 was the input, right? This is the input and this is the output. So for F2, for filter 2, who is the input? Filter 1. So this 600 record, I can keep it into the memory, and I will read it from the memory only. From where I'm going to read, I will read it from the memory only. So whenever you are reading it from the memory, it is very faster. And after you read it, once you are done with the filter, finally you are going to store your data. So write operation is coming in the last only. And but in the MapReduce, write operation is coming whenever you are doing intermediate result. For each and every intermediate result, you need to write it. But in Spark, you can keep your intermediate result into the memory. And that is the reason people are saying that Spark is 100 times faster than MapReduce. 100 times faster than MapReduce. And that is the reason in the big data system, that is the reason in the big data world, this Spark is having huge demand in the market. Because first thing is, it is free of cost. Free of cost means this Spark is used by the Apache. Any product which is coming from the Apache is completely free of cost. So first thing is, it is free of cost. Second thing is, it is faster. And what else we need, right? And it has, Spark can be written with multiple language also. Spark can be written with multiple language. Like, let's say you are a Java developer, so you can have a Java plus Spark combination. Let's say you are a Scala developer, so you can have Scala plus Spark combination. Let's say you are a Python developer, you can have Python plus Spark combination. So in our training, we are going to learn about the Python plus Spark. So those people who are comfortable with Python, they can easily understand the Spark technology. So what I mean to say, irrespective of any knowledge, Spark you can return it. Spark you can use it. Spark you can use it. That's the reason we are using a Spark, and Spark has a very good demand in the market. Spark has very good demand in the market. That is the reason it has very good demand in the market. So till now, whatever we have discussed, are you able to understand? Okay, I see everyone is saying yes, yes. All right, thank you. To understand, nice. 8 people, 9 people. Okay, it's easy, right? It's easy, right? It's not that difficult. Spark is easy. Hadoop is easy. Big data is easy. That's not difficult. Okay, so I see 100% result. Everyone is able to understand. Thank you. Okay. Now, so nowadays, if you go for an big data interview, okay, nowadays, if you go for an big data interview, many people are focusing on Spark, and there is no restriction like you should go with the Java or Scala or Python. That kind of generic technology it is. Like, if you are working as a Java developer, you can switch your career from Java to Java Spark. If you are working on some hands-on experience with the Scala with Spark is pretty much really good. Python and Spark is really booming in the market. Java and Spark is not that like mostly used. Mostly it has been used with the banking systems. Scala and Spark and Python with Spark is mostly used in the market. All the mid-scale company or big company, they are trying to do with the Python only, because Python is faster. If you want to write down the code the faster development is happening along with the Python. So many projects they are trying to go with the Python. So because Python is having huge number of packages available, modules available, you can easily use that, and that makes your development very faster. So we are going to discuss about the Python basic in our class, and along with that Spark is definitely there. And in the Spark, the good functionality about the Spark is like, if you are good with the SQL, okay, let's say you know each and everything about SQL, your query are perfectly fine, let's say you are very much comfortable with the SQL, then the good thing is that if you are comfortable with the SQL, then straight away you can write down your SQL query inside the Spark also. What I mean to say, let's say there is I want to create a table and I want to insert some data. Whatever SQL query syntax are there na, or let's say you want to do the joining of two table, complete SQL query also you can write down under the Spark SQL. There is a component there is there, we called it as Spark SQL, in which you can write down your complete SQL query itself. You can write down that. And that is the reason, that is the reason Spark play a very, very important role in the market, that it is very much dynamic, uniform. It support everything actually. It support everything means, let's say you want to know about, you want to do the SQL programming along with the Spark, you can do that. If you want to use some graphics, you may have heard about this technology, you can do that. Let's say you want to do with the machine learning, you can do that. Machine learning things you can use along with the Python. You have a core functionalities provided by the Sparks are there, and many more things are there, and that is the reason it has very good demand in the market. Whenever you are mentioning Spark in your resume, irrespective of Spark with Python or Spark with Scala, that's not important is Spark. Important is Spark. So if you ask me that on which factor you can get a job nowadays, so I would suggest that you should start learning the Spark along with Python, or Scala also you can take. You can have some knowledge about the SQL, that is very important, because nowadays this is a data engineer field in which data analytics also coming. So having a knowledge about SQL is very much important for everyone. Having a knowledge about the Linux is very much important here. Why? Because I discuss about the HDFS, right, which is a Hadoop file system. Hadoop file system, when you want to tackle with the Hadoop file system, it is completely a Linux only. If I tell you one example, HDFS, DFS, ls. If I use this command, this ls everyone know, right? This is a Linux command which will list down the files and directory from that file system, right? So this is the just a prefix of your Hadoop file system, and this is a Linux command. So those people who are comfortable with the Linux, they can easily understand the Hadoop file system. Those people who are comfortable with SQL, they can easily understand the Hive. Those people who are comfortable with any programming, let's say you are good with Java or C or C++, you can easily understand Spark with Python. You can easily understand that. And nowadays, like, having a knowledge about the cloud technology plan also very important role. So I'm not focusing on one technology, like you should know GCP only, or you should know Azure only, or you should know AWS only. Having a knowledge about one technology like GCP or Azure or AWS, you take any cloud, but you should know that how to deploy your Spark code in this cloud system. So that's a very good thing that everyone should try before you join as a data engineer. Okay, whenever you are thinking that, okay, it's time to kickstart my journey as a data engineer, these are the prerequisites are there, and this is the way you can easily understand this technology. Okay, so one more important thing is there, many people are asking me that, okay, we are done with the Spark, okay, we know that how to write down the Spark programming now, but I want to understand about how you can schedule it. Schedule it means, let's say I have write down the pipeline in which the data is getting loaded, this is my data, that data is getting loaded, I'm going to process it, and finally I'm going to store it, right? So this is a complete Spark program which needs to be run automatically, right? This needs to be scheduled somewhere on some particular time. So for that you can use crontab, which is a free scheduler. And nowadays in big data system they are providing one more schedule is there, we call it as a airflow. Airflow is something which is widely used, okay, widely used in the market. Airflow is something which is widely used in the market. And previously the people were using one more scheduler was there, and we called it as a 𝐓𝐢me. So 𝐓𝐢me was a scheduler, but nowadays I see the more demand is coming to the airflow, in which we are going to learn about how you can schedule your Spark related jobs also by using this airflow. So that's the importance of scheduler. And crontab, everyone know, not only just Hadoop related job. If you want to configure your any related job, any type related job, you can configure that by using crontab. So these things also we are going to learn in our class. And yes, we are going to see how to run your jobs, how to run your Spark job on the cloud also. We are going to see how to run your Spark jobs on your AWS cloud. So we are going to discuss AWS cloud also. So whatever things which are required for the data engineer, with respect to of AWS, like your EC2 instance and all those things, EMR, we are going to discuss in our class related to the AWS also. So again, like the trainings we are going to start from tomorrow. 2 days of demos that we have started like from yesterday and today, it's getting completed today. So we are going to continue this class from tomorrow. The timing will be again 6 to 7 p.m. IST timing. Okay. So we are going to discuss about like all the big data system, Hadoop. Inside the Hadoop we have components like Hive and all. Okay, we are going to discuss about Python is there. So Python we are going to discuss Spark. Okay, AWS we are going to cover Airflow. The most important is Hadoop and the Hadoop ecosystem. Okay, so we have Hadoop architecture and all those small things are there definitely. Okay, I don't want to go into that much details, but yes, all the links and everything, if you go to our website, learnomate.org, you can see all the details over there. One more thing that I want to tell you here, that if you go to the YouTube and if you search here with the Learnomate technologies, if you go here with the Learnomate technologies, you can see here that we have around 17,000 followers are there on our YouTube channel. So we have a good name in the market. Okay, so you can see all the details. We have already uploaded 919 recording. So those who want to understand free of cost, you can go to our YouTube channel, subscribe here, try to understand how we are doing the things. Okay, and those who are interested to take this class as a real time things, so our main focus is to crack the interview. So today also one of our students, he got placed into the company. So basically our focus is real-time project oriented stuffs. Okay, so that's the things. Yes, we are going to discuss about the projects also in this class. Okay, so that project you can discuss with the whenever you go for an interview, you can discuss there and you can try to crack the interviews. Okay, so if you go to the Google and if you search with data engineer jobs, okay, you can see plenty of jobs are available on the Naukri.com. You can see a lot of jobs, 1000 plus data engineer jobs are available on the LinkedIn, Naukri.com, Indeed. Data engineer is having a really big demands in the market. You can see all the big companies including your IBM, Accenture, TCS, Wipro, and everyone is aware about that. So I already work with all this company as a data engineer. So if you want to follow me, you can visit, you can go to the LinkedIn, you can follow me with my name. You can see the details over here and you can follow me so that you can get more and more details about me. So if you want to see my profiles, You can go here, you can see here that I already work with the LTI, Wipro, Infosys, Cognizant, all these big MNCs over here. Okay. So that's all about me, that's all about the trainings, okay, program. Okay, so let me know if you need any things we can discuss over here. So if you want to know more about the reviews and all, you can check out here with the name Learnomate Technologies. Okay, and you can see the things over here. Okay, you can check the reviews and all. Okay, so we have quite good reviews. So if anyone have any questions, you can unmute and you can ask the questions. Okay, so till now, like whatever we have discussed, I hope you uh, enjoyed the sessions, whatever we have discussed till now, and you people are able to understand. Okay, so we'll keep on doing all these sessions like this only. It will be free, some of them all paid, something like that. Okay, and if you want to understand more and more free of cost, definitely you can visit our YouTube channel. Many videos are there. Okay, and you can try to see, like, how we are doing the things. That's the reason we have taken this demo. So those people who are interested to join our this big data engineer program, they can WhatsApp us, or they can directly call us on the number 77570 on this number, or you can drop an email message to the info. It's info@learnomate.org. On this email ID you can drop an email message to us. Okay, so I see the poll is 100%. Thank you so much for joining, guys. If anyone have any question in last one moment, you can ask me. Otherwise we'll continue in the class from tomorrow. Thank you. Bye bye.